November 10th, 2023, 7:42 p.m. The ground beneath the Icelandic fishing town of Grindavík began to tear itself apart. Not slowly, not with warning. The earth ripped open like paper, swallowing roads, splitting homes down their centers, dropping entire neighborhoods into freshly born chasms. In 6 hours, 22,000 earthquakes hammered the town. 22,000. The magma reservoir 4 miles below had finally breached the surface barrier, forcing 47 inches of lateral movement through solid rock and creating a valley half a mile deep where streets had stood that morning. 4,000 residents fled into the November darkness, leaving everything behind. The town sat directly above a 9-mile crack in the Earth's crust, and at the end of that crack, scientists detected what everyone feared: magma, rising, fast. The volcanic system that had slept for 800 years had awakened, and preliminary estimates suggested it would erupt for the next 600 years, maybe longer. The question wasn't if Grindavík would be destroyed. The question was how much of Iceland would burn with it, because directly north of the doomed town sat the Svartsengi geothermal power plant, supplying heat to 30,000 people across the frozen peninsula. If lava reached those turbines, an entire region would go dark in the middle of winter. Roads would be severed, the international airport would lose power, the famous Blue Lagoon would vanish beneath molten rock. Iceland had one chance, one impossible, desperate, never been done at this scale chance. They would build a wall, not of concrete or steel, those would melt like candle wax. They would build a wall of earth and volcanic rock, piled so high and so wide that when the volcano erupted, when 2,200-degree lava came pouring out at the speed of a river, the wall would hold. And to build that wall before the eruption, they would need the largest, most powerful bulldozers on Earth. The engineering firm Verkis knew exactly what machine they needed. The world's most powerful production bulldozer, the Caterpillar D11, 40 feet long, 15 feet high, tracks nearly 10 feet wide that can climb a 45-degree slope and punch through obstacles that would shatter lesser machines. 850 horses thunder under its hood going forward, 957 screaming in reverse. More power than a NASCAR race car, more torque than a freight train locomotive, and every ounce of that mechanical fury would be needed, because what Iceland was attempting had never been accomplished at this scale. They had to move 4.5 million cubic yards of earth, enough to fill the Empire State Building 6 times over, in weeks, maybe days if the magma kept rising. Each D11 could push 45 cubic yards per pass with its massive blade, but that meant thousands upon thousands of passes, working around the clock, racing against seismic readings that showed magma climbing closer to the surface every single hour. Construction manager Einar Már would later say it must be a record for earth-moving speed, but in November 2023, nobody was thinking about records. They were thinking about the gas detectors screaming warnings, about ground temperatures spiking, about the very real possibility that the volcano would erupt before the barriers were finished, and 30,000 people would freeze in the Icelandic winter. The D11s roared to life. The race began. Picture a machine the size of a small house, painted Caterpillar yellow, its blade wider than a 2-car garage. Now picture that machine clawing into volcanic rock and frozen earth, its 14.5-foot-long tracks biting into terrain that was fracturing in real time from continuous earthquakes. 700 to 1,400 earthquakes per day, hammering the peninsula, opening new cracks, destabilizing everything. Ground subsiding nearly 2 inches every 24 hours. Fissures splitting roads. Buildings tilting as their foundations dropped away. And through all of it, the D11s kept pushing. The operators worked in rotating shifts, never stopping. The machine's cabs were pressurized survival capsules, the only protection against volcanic gases seeping up through the fractured ground. Sulfur dioxide, carbon dioxide, hydrogen sulfide. Any of them could kill within minutes if the positive pressure system failed. 360-degree camera systems gave operators visibility through the ash and steam, because looking out windows with your own eyes could mean death from toxic exposure during maintenance stops. The cab wasn't just climate controlled, it was life support. The blade on a D11 isn't just big. It's engineered for apocalyptic conditions. High tensile steel construction resists torsional stress when biting into boulders the size of cars. The heel clearance angle lets it penetrate hardened volcanic crust like a knife through butter. Extended tilt cylinders reposition the blade in seconds when the approach angle changes, because when you're building a wall against lava, every single second counts. Technology automatically optimizes blade load, squeezing 15% more productivity from operators already working themselves past exhaustion. They built the barriers in sections, arcing them between high points in the terrain to create artificial channels. The barriers would rise 70 feet high, 180 feet wide at the base, extending for miles. The math was brutal. To contain lava erupting at 70,000 cubic feet per second, you need mass. Incredible, overwhelming mass. The kind of mass that only millions of tons of earth can provide. But here's what kept everyone awake at night. Could dirt really stop molten rock flowing at 2,200 degrees Fahrenheit? The physics seems impossible at first. Lava is liquid rock, superheated, unstoppable, capable of melting through steel and concrete like they're tissue paper. But lava has one weakness. It solidifies around 1,400 degrees, still hot enough to ignite wood at 50 yards, still hot enough to boil water instantly on contact, but solid. And solid lava can't flow. When molten lava hits a massive earthen barrier, the outer layer cools through direct contact with cooler material. That creates a crust. The crust acts as insulation. Interior lava piles up behind it, thickening, slowing, creating more surface area for more cooling. It's a self-reinforcing cycle, but only if the barrier has enough mass to withstand the pressure. Only if it's positioned correctly to force the lava to thicken and slow before it can spread. And only if it's completed before the eruption begins. The D11's track system became critical in ways no one had anticipated. Each track stretches nearly 15 feet long, distributing the bulldozers 230,000 pounds across so much surface area that ground pressure drops to just 20 pounds per square inch. That's less pressure than a human footprint. On terrain that was fracturing, subsiding and trembling from constant earthquakes, that low ground pressure meant the difference between a machine that could work and a machine that would sink into the shattered earth and die there. The undercarriage took punishment that would destroy ordinary equipment: sharp volcanic rock, basaltic fragments, obsidian shards, all grinding against the tracks with every foot traveled. The D11's suspended undercarriage absorbed the shock, reducing impact loads by 50%. Lifetime lubricated rollers meant less maintenance, which meant less time exposed to toxic gases during service. Every design choice, every engineering decision, suddenly became life or death. And then the thermal stress began. As December arrived, ground temperatures kept climbing. Magma was close, very close. The D11's cooling system, designed for the hottest deserts on Earth, found itself facing something far worse: radiant heat from underground magma chambers superheating the soil. The machine's 475-gallon fuel tank provided extended operation without refueling, because retreating to refuel could cost hours they didn't have. The high-performance cooling module, with its 46-gallon capacity and automatic reversing fan, ran at maximum output, fighting to keep hydraulic fluid temperatures below the failure point of 180 degrees. If hydraulics overheated, the blade would lock. The machine would die. The barriers would remain unfinished. One worker, checking gas levels a week before the first eruption, got readings that sent everyone scrambling. Magma was less than a quarter mile below their feet. The barriers weren't finished. Einar Már made the call. They would work in shifts around the clock, pushing the machines and crews beyond any safe operating limit, because the alternative was watching the power plant burn and 30,000 people freeze in the dark. The D-11s screamed through the night, their LED lighting systems illuminating the barriers rising foot by foot against the black Icelandic sky. 45 cubic yards per pass, another, the blade slamming down, biting in, hydraulics straining as 330,000 pounds of drawbar pull dragged earth and rock into position, backup alarms wailing, tracks churning, diesel engines roaring at full throat, and beneath it all, the rumble of the earth itself, pregnant with fire, ready to burst. December 18th, 2023, 10:17 p.m. Seismometers exploded with activity. The eruption had begun. A fissure 2.5 miles long ripped open northeast of Grindavík, vomiting lava fountains 200 feet into the winter sky. Orange fire illuminated clouds of volcanic ash and steam. The sound was indescribable. A freight train mixed with thunder, mixed with the earth screaming. In the first hours, lava erupted at a rate equivalent to a major river. 70,000 cubic feet per second pouring out of the crack in the world. It flowed at walking speed, glowing white hot at its core, cooling to orange at its edges. Nothing could stop it, nothing except the barriers. The question everyone had been afraid to ask was about to be answered. Lava hit the first barrier section at 2 in the morning. The earth wall stood 70 feet high, layered with volcanic rock and compacted soil that the D-11s had placed with precision. The molten rock, glowing orange-white in the darkness, climbed the barrier face. Steam erupted where residual moisture vaporized instantly. The heat was so intense that observers 300 feet away had to shield their faces. The lava slowed, thickened. Its outer layer cooled, forming a black crust that cracked red with interior heat. Behind that crust, more lava piled up, increasing pressure, but also increasing surface area, accelerating cooling. The physics worked, the barrier held. But this was just the beginning, because the volcanic system that had awakened wasn't finished, not even close. January 14th, 2024, 7:57 a.m. A second eruption began, and this one was different. The fissure opened just 1,500 feet from Grindavík's edge. Lava fountains erupted directly toward the town. Equipment operators had seconds to react. $6.5 million worth of bulldozers, excavators and trucks sat at construction sites with molten rock advancing at half a mile per hour. Emergency evacuation missions launched immediately. Operators fired up the D-11s and drove them out under advancing lava flows. The machine's 957 reverse horsepower evacuating them faster than the lava could follow. Every piece of equipment made it out. Every operator survived. Then, at 12:10 p.m., the nightmare scenario unfolded. Another fissure opened inside the defensive perimeter, just 660 feet from the town's buildings. The barriers had been positioned to stop lava from the north, but this fissure was between the barriers and the town. There was nothing to stop it. Lava poured directly toward Grindavík's homes. 3 buildings caught fire from radiant heat before the lava even touched them. At 2200 degrees, the thermal radiation ignites wood at 100 feet away. The houses burned, then vanished beneath black rock that glowed red from within. 3 homes gone in minutes, and the flow was still advancing. Iceland's president made a statement that afternoon. What we all hoped would not happen has come to pass. The barriers had failed, or had they? Engineers analyzed what happened. Yes, 3 homes were destroyed, but the main lava flow from the northern fissure, the one that could have obliterated dozens of buildings, had been stopped cold by the barriers. The division manager at Verki stated it clearly. The barriers held the majority of lava flow. Without those walls of earth that the D11s had built, the entire town would have been buried. The barriers had done exactly what they were designed to do. They just couldn't defend against a fissure that opened behind them. So they built more barriers, bigger barriers, extended the defensive perimeter. And the D11s went back to work because the volcano wasn't finished. February 8th, 2024, 6:03 a.m., third eruption. The hot water pipeline supplying 26,000 residents was destroyed. Engineers rebuilt it in 4 emergency days while residents went without heat in the middle of Icelandic winter. May 29th, 2024, fourth eruption. Then August 22nd, the fifth and the most massive yet. Lava erupted at 70,000 cubic feet per second during initial phases, the highest flow rate ever recorded in the series. For comparison, that's equivalent to the water volume of a major river, except it's molten rock flowing at 2,200 degrees. The fissure extended to 4 1/3 miles in total length. In the end, 80 million cubic yards of lava erupted, covering 9 square miles of landscape, and the barriers held. The Svartsengi geothermal power plant, supplying heat to 30,000 people in the middle of winter, remained untouched. Major highways stayed open. Power transmission lines continued functioning. The international airport maintained operations. Infrastructure worth hundreds of millions of dollars, protected by walls of earth that wouldn't exist without the Caterpillar D11. By September 2025, 9 separate eruptions had occurred. 9 times the earth had split open and bled fire. 9 times lava flows threatened to consume everything in their path. And 9 times the barriers that the girthy D11s had constructed stood between civilization and obliteration. But understand this, the cost was staggering. Grindavík itself remained evacuated. The town had become a ghost town, patrolled by emergency crews, its residents scattered to Reykjavik and other cities, watching live streams of orange lava advancing toward their neighborhoods. Raquel Lind, 42, personal trainer and mother of 3, spent entire weekends glued to her screen. "I was raised knowing that Reykjanes would crack," she said, "but I never thought it was actually going to happen." 4,000 residents shared this nightmare, watching their homes threatened in real time by flows moving at walking speed, slow enough to track every meter, fast enough to be unstoppable. The government eventually offered to buy homes, acknowledging what everyone knew. Grindavík's future was uncertain. Some buildings had been destroyed. Others were damaged beyond repair from the constant earthquakes and ground subsidence. The psychological whiplash of evacuation return cycles devastated the community. Evacuated in November, allowed briefly to return in December, forced out again and again and again. Through 9 eruptions, each return offered hope. Each new evacuation destroyed it. And here's what keeps scientists awake at night. The eruptions aren't stopping. They're not even slowing down. Scientists studying the underground magma reservoir calculated that it would continue for centuries, maybe 300 years, maybe 600. The volcanic system that had slept for 800 years has reawakened, and it won't sleep again in any of our lifetimes, or our children's lifetimes, or our grandchildren's lifetimes. Which means the D11's work isn't finished either. Even now, as new seismic data comes in, as GPS measurements detect ground inflation indicating magma accumulation, the bulldozers stand ready. Because this isn't a crisis with an end date. This is a permanent new reality. Iceland has chosen to fight a volcano that will outlive generations, and they're fighting it with the only weapons that have proven effective: earthen barriers, precision engineering, continuous monitoring, and the world's most powerful bulldozers. The Caterpillar D11 wasn't designed for this. It was designed for mining operations, for moving overburden in coal fields, for massive earth-moving projects in deserts and mountains. But when Iceland needed a machine that could work in hell itself, that could operate for 24 hours straight on fracturing ground with toxic gases seeping up and magma rising below, that could push through volcanic rock with enough power and precision to build walls capable of redirecting rivers of molten stone, there was only one machine on Earth that could do it. 850 horsepower, 230,000 pounds of mass, 45 cubic yards per pass, working around the clock in darkness and volcanic ash, with the ground shaking beneath its tracks and lava fountains lighting up the sky. The D11 didn't stop the volcano. Nothing can stop a volcano, but it did something equally remarkable. It bought time, protected what could be protected, saved infrastructure that keeps 30,000 people warm through Icelandic winters, proved that even when the Earth itself erupts, even when forces measured in millions of tons and thousands of degrees pour forth from cracks in the ground, human ingenuity and mechanical power matter. Construction manager Einar Mar reflected on the impossible task. "We've moved about 4.5 million cubic yards," he said. "I think it must be a record. We came here for what was supposed to be 3 weeks to build one barrier. It's been almost 2 years now." Workers who expected a brief emergency deployment found themselves in an indefinite battle against forces that would continue for 600 years. But they kept working. The D11s kept pushing. Because when you're facing geological inevitability, when nature unleashes its most destructive forces, when the choice is between fighting or surrendering, there's really only one choice for those who build, who create, who refuse to accept that some problems are too big to solve. The volcano will erupt again. The seismometers are already detecting new activity. Magma is accumulating in the reservoir 4 miles below. The next eruption could happen tomorrow, or next month, or next year. And when it does, the D11s will be there. Engines roaring, blades dropping, tracks churning through volcanic rock, building humanity's last line of defense, one 45 cubic yard push at a time. Because that's what heroes do. They show up when the odds are impossible. They work when everyone else has evacuated. They push earth and rock against flowing fire and refuse to stop until the job is done. And sometimes, just sometimes, they win battles that everyone said couldn't be won. The barriers stand 70 feet high and 180 feet wide, arcing across the Reykjanes Peninsula like scars carved into the earth itself. Permanent geological features that will remain for centuries. They've held through 9 eruptions. They'll be tested again. Maybe they'll hold. Maybe they won't. But Iceland made its choice. When the earth itself tears open and bleeds fire, we don't surrender. We engineer solutions to impossible problems. We deploy 230,000-pound bulldozers. We move millions of cubic yards of earth. We build walls against the apocalypse, and we dare the volcano to try again.